Hello once again. Welcome to the Gillespie's online learning channel, created specifically for geography and social studies students right here on YouTube. This particular video will be looking specifically at fourth form geography, or maybe for fifth formers, students who are doing CSEC geography, and particularly looking at the topic limestone rocks and limestone landscapes, also called karst topography or karst landscapes. So in this video, we'll be looking at the widespread distribution of limestone rocks, one of the most widely distributed sedimentary rocks all over the globe. As you can see on the map, represented by the red areas, limestone rocks are one of the most widely distributed sedimentary rocks on the planet. And so we're going to be looking at limestone rocks and limestone features, karst topography, as we study the features formed in areas predominated by limestone rocks. My name is Derrick Gillespie. If this is the first time you are joining this channel, I am a teacher at Monroe College in St. Elizabeth in Jamaica, and I welcome you, especially fourth and fifth formers who are preparing for their external exams, CSEC exams, as we look at the topic limestone landscapes and or karst landscapes or karst topography and limestone rocks. Welcome and success to you as you study this topic, limestone rocks and karst landscapes or karst topography.
Imagine waking up one morning to find that the house next door had disappeared down a hole. What seems like a stretch of the imagination is not far from an actual occurrence. Guatemalans and the world were shocked by a humongous sinkhole that suddenly opened up in Guatemala City, swallowing a 3-story building and a good chunk of road. This sinkhole, by its sheer size, is one for the record books, but sinkholes are common in limestone terrain. In these types of landscapes, striking and unusual features and rock formations abound, though many may be hidden from sight by vegetation or because they are underground. Limestone areas are characterized by karst terrain, rocks with grooved and pitted surfaces, dough lines, springs, disappearing streams, depressions, clints and grikes, sinkholes, caves, and underground lakes and rivers would be found in such landscapes. What is it about limestone that produces karst scenery? Limestone is a hard rock, but it can be dissolved by weak acids in water. not realize it, but rainwater is slightly acidic. When rain falls, it mixes with the carbon dioxide that is present in air and forms carbonic acid. This weak acidic solution falls to earth and becomes even more acidic as groundwater due to the presence of carbon dioxide in soil. Let's see what happens to water as it travels across an area composed of limestone rock. As you can see, carbonic acid attacks lines of weakness. Many start as hairline fractures, but become slowly enlarged over time as the limestone rock is dissolved. This process of weathering is called carbonation. Over the course of thousands and millions of years, karst terrain is the result. Let us look more closely at some specific features formed by carbonation of limestone rocks. Weak acid in rainwater can undermine rock, creating rock cavities below the surface of the earth. Depending on how the line of weakness is aligned, different types of features may be produced. Depressions or dough lines, which are basin-like, can result from collapse of a rock cavity that developed along a horizontal line of weakness. Sinkholes, also called swallow holes, can develop from the collapse of rock overlying cavities formed along vertical lines of weakness.
All right, so there you have been introduced to the basic idea of what we mean by karst landscapes. Areas which are predominantly limestone rocks, which are affected by the process of carbonation. And so as the rainwater or groundwater reacts with limestone rocks, eventually eating away at the rock itself, various features are formed. And we will now continue to look at some of these features. Here we go.
Conical hills are formed by water running down a limestone slope. At the top of the slope, movement of the water would be slow. Its effect on the surface of the slope would be minimal. As the water travels further down, gathering speed, stones and other debris, the surface of the slope is abraded or scraped away at a more rapid rate. This explains the slope being more gentle at the top and steeper further down the sides. One of the most striking examples of a conical hill can be found in Bull Bay in the parish of Kingston and St. Andrew.
Right here in Jamaica.
We are going to the United Kingdom to see an unusual landform that results from solution weathering or carbonation of limestone sheets.
Of course, right there in Europe.
This limestone pavement looks as if it has been chopped into blocks. The deep grooves are called grikes and the blocks clints. These striking features formed relatively deep under the soil as a result of carbonation. Water-carrying carbonic acid slowly widened the vertical lines of weakness, the joints in the rock. Over time, these features may be exposed through erosion of surface material. Clints and grikes are found in areas where there is snow and glacial action. The rock makeup of the island of Jamaica is approximately 70% limestone. This explains the presence of many interesting features, though many go unnoticed. Cockpit Country stands out as one of the most vivid examples of karst scenery around the world. The term karst is derived from the Slovenian term kras, meaning a bleak, waterless place. This description does not seem to quite fit the hot, humid Cockpit Country, which receives high amounts of rainfall. However, water drains rapidly down sinkholes in the array of basins or pits dotting the limestone plateau. Cockpit Country is a protected resource. As one of the few stands of virgin forest in Jamaica, it is a habitat for many species of flora and fauna which are endemic to our island. Ecological value is just one strand of the value chain relating to limestone resources. More typically, though, limestone is quarried for several purposes. Crushed limestone, also called aggregate, is used for the construction of roads. Limestone is an ingredient in the manufacture of cement and fertilizer. Tiles cut from limestone are used in construction of high-end residences and buildings. Some of the more interesting features of limestone terrain may be included in the tourism offerings of a country. Limestone has many possibilities. Investigating the uses of limestone features and resources where you live and places you visit are interesting ways to learn more about this rock.
Okay, so far, students, you have been introduced to some of the basic concepts as it relates to limestone topography, karst areas. My advice is that you use your summary notes, use your textbook to guide you as you explore some of the new words and concepts and features that have been introduced in this video. Pause the video, rewind, listen again to the short video clips, and ensure that you compare them with your textbook and your summary notes. Now, at this point, we're going to go a little deeper into the study of the Caribbean environment as it relates to karst topography and limestone rocks. So here we go.
Mystery awaits those who dare to venture into and explore any of the world's karst landscapes. However, the mysteries of our Caribbean karst landscapes are unlike those found in other parts of the world and are truly something to witness. What really are karsts and how are they formed? Karst is a unique landscape made of a distinct type of limestone terrain. Most karst landscapes are formed in areas where limestone and other similar rocks are common. Rainwater combines with the carbon dioxide in the atmosphere to produce a weak acidic solution, which slowly dissolves away the limestone. Tiny cracks gradually develop in the limestone and may spread and grow larger as more and more surface water flows through them. Over time, these fractures eventually increase in size to form wide mouth openings called sinkholes. As this process continues over the years, complex underground drainage systems and extensive caves begin to develop. The unique and spectacular limestone formations in these caves, stalactites and stalagmites, are formed when calcium carbonate and other minerals removed by dripping water is deposited in these locations. So karst is really the result of complex relationships between water, vegetation, soil, rock, and the atmosphere.
We're in the Green Grotto and the Runaway Cave, which is a tourist attraction. For the past 60 years, it's one of the most unique caves throughout the world, and we are so Green Globe certified here. The cave, our Jamaica itself, it was once submerged. So it's the seawater that erode all these rocks away and leave all these caverns. So these are natural form covered by the seawater itself. Why it's so clean down there? Because it doesn't expose to sunlight, and you have little acid in it that prevent algae or any vegetation to grow. And we have the sea and the spring water. So it's a mixture of water, so it's not a stagnant water.
One such karst phenomenon right here in the Caribbean is Harrison's Cave in Barbados. Formed from a type of beautiful crystalline limestone which glisten in the natural light, Harrison's Cave is one of the most magnificent natural formations of the Caribbean. Venturing through the mile-long cave, one encounters an abundance of bubbling pools and deep streams, waterfalls, and stalactites and stalagmites. In many places, the stalagmites have reached up to join the stalactites to form amazing columns. Harrison's is a living cave unlike most in the world, as water rich in calcium continues to drip from its ceiling and add to the karst formations.
Powerline Stone is a solid rock, however it is soluble, it is only dissolved rather, not by plain water itself. It must have rainwater, and that slight acid content in rainwater, it slowly dissolves. And this is because the rainwater, as it passes through the atmosphere, it collects the carbon dioxide, then it passes through the earth itself, and by passing through the earth, it collects more carbon dioxide through the soil and decaying vegetation. So this creates a very mild, the interaction between the rainwater and the carbon dioxide creates a mild, what you can call carbonic acid. It's like the fizz in soda. When this comes into contact with the limestone, it gradually erodes it. And it comes through, this is what we call the solution process. It passes through and it filters. This is what you're seeing here now, these cave showers. And these cave showers carry minuscule bits of the dissolved calcium carbonate. Then a reverse process happens as it comes through the limestone and hits the open air inside the cave. Since the water can no longer hold the carbon dioxide, it leaves behind tiny deposits. They're not visible by the human eye. And the process it takes, the experts tell us it takes 120 years for 1 cubic inch of a formation to grow. So you can see it's a very slow process and it's very, very delicate formations.
The unique climate of karst landscapes provides a habitat for many animal species. Long before one even sees the gaping portal of Trinidad's Arepo Cave, the sound of squawking oilbirds beckons you to press on. Oilbirds are rare and protected animals, and the Arepo Cave system is one of only a few places where they can be found. Though they are nocturnal creatures, these animals are very active during the day, as the presence of humans usually sends them flying about excitedly in an effort to protect the ones that are roosting in the cracks of the cave walls.
The oil bird is a very interesting bird in that it's the world's only echolocating bird, and the reason for this echolocation, which is very much like bats, it's just like bats, it lives in caves. So if you go in a cave, you'll hear beside the screams, you'll hear this, and that's the echolocation. It's bouncing off the walls of the cave. So when it's absolute dark, they see using echolocation. What also makes oil birds interesting is what they get their name from, oil bird, and that is they feed on the fruits of certain palms, and these palms are very fatty. There's a lot of oil inside of them, and they come back to where the cave is, and they regurgitate to the young these very fatty oils from the fruits. The juveniles feed on this, and from these fats they can really get to twice the size of an adult, and it's all just a lot of fat and so inside of them. So what used to happen many years ago is Amerindians, and even to recent times, they used to take them and boil them, and that would bring out all the fat, and they would scrape the fat off the top of the water and use that oil from the fats for cooking and other uses.
Besides providing a habitat for many species, caves are also a valuable source of information on human history, evolution, and natural resources. The dramatic topography of this, another Karst terrain in Jamaica, was sculpted by millions of years of erosion. These rounded peaks and dome-shaped depressions of yellow and white limestone form Jamaica's Cockpit Country, so named because of their resemblance to cockfighting pits.
The white limestone in the Cockpit Country is 99% calcium carbonate and it's very, very pure. Compared to the yellow limestone, which has a high degree of impurities within the yellow limestone. The yellow limestone functions as an aquiclude, whereas the white limestone functions as an aquifer. And the purity of the white limestone, its high degree of classification in the Cockpit Country, for instance, high tectonic activity, all leads to a very high permeability, high transmissivity, in that it moves water through a unit of the limestone very, very rapidly, and you'll get rapid flows underground in conduits, what people may call conduit flow or compartmentalized flow. And local people tell you there are rivers underground. That's basically what it is. You can actually walk through some of these underground systems and see the rivers flowing through them. And that was made the Cockpit Country very unique. Formations like the Cockpit Country, which is a purely limestone area, highly karstified limestone area, that acts as a recharge area from which water is recharged to the aquifers. There are no rivers in the Cockpit Country, but at the fringe of the Cockpit Country, to the north and the south, a lot of our groundwater appears to feed major rivers.
Have you ever seen mountains as white as snow here in the Caribbean? Witness yet another fascinating karst landscape, the Chalky Mountains, located in the mountain regions of Barbados. Devoid of any vegetation or sign of animal life, the Chalky Mountains are made of very dry calcium carbonate and are essentially huge chunks of crumbly limestone. Caves and karst landforms are yet another attraction for tourists and sightseers. However, improper human activity can have detrimental effects on these landscapes, destroying the cave biota. Since karst systems are linked to local groundwater supply, there is a risk of contamination and pollution of water supplies from human interaction in these areas. Furthermore, pesticide and fertilizer usage, mining and drilling, urban development, sewage disposal, and even recreational activities can lead to profound disturbances and destruction of the delicate ecosystems of the karst landscape. Other than being just marvels to behold, caves are of great importance. They are a source of water and mineral resources such as calcite and gypsum. So, let us be mindful of the value and importance of these natural wonders to not just the environment, but also our own lives and well-being.
Alright, so there you have been introduced to some of the basic concepts and the features as it relates to the limestone topography, karst topography, and limestone rocks. Now, as I close this video, I'm going to be sharing on screen some of the surface and underground features which are common in karst areas. And as you're seeing on screen, my advice is to pause the screen and to take a look at the features that are above the ground, surface karst features or limestone features, and features which are below the ground or underground karst or underground limestone features. Make sure that you use your text and your summary notes to carefully define and describe the formation and appearance of these various features, how they are formed, what they look like, whether they are above the ground or below the surface. Now, to close, I'm going to be sharing on screen some helpful study guides, summary notes. I'm going to scroll the notes very slowly, and you are encouraged to pause the screen and make note of important points and concepts, or you can take screenshots of the important points as it relates to the topic. Alright, so there you have it, students. Let me hope that this short video, along with the summary notes, video clips combined, were helpful as you study the topic limestone rocks and karst topography or limestone landscapes. Thank you for listening. Success to you.